Okay, so we're going to be talking about solving equations, which is something we've been doing every day in our bell work. You should find it not difficult. However, as we go through it, as we get towards the end of this lecture, there are some much more difficult problems. Okay, so we're going to be doing equations and problem solving. Okay, the first equation is, again, most of you should be able to just do this in your head. Okay, but it's about learning the steps. It's about learning the steps. Because if you don't learn the steps, you can't accomplish it. So what's step one going to be? Zoe?
Going to subtract 1 from both sides.
Correct. Step one, we subtract 1 from both sides. Because plus 1 minus 1 is going to cancel itself out. And we're going to end up with 3x equals 6. Okay. What's the next step, Kelby?
Look at the problem. Oh my gosh.
Jacob? Divide both sides by 3. Divide both sides by 3. And we end up with x equals 2. Okay, and I'm sure that all of you had that done already. But when you're solving for a variable, when you get your answer, you should always go back and try it in the equation and make sure it works. You should always go back and try it, because sometimes you'll find that the answer you got doesn't work because you're either got a negative and it's a positive, or you've got it as positive and it's negative. So if you go back and try it, then you find out. Next equation, 5x minus 6 equals 14. Okay, Kelby, what's the first step?
Because you don't know.
You don't pay attention.
Yeah,
Dominic? Right. Add 6 to both sides. Add 6 to both sides. That's going to give us 5x equals 20. So, our next step, Eddie? Donovan? Divide by 5. Divide both sides by 5. Okay? That way we get x equals 4. Then go back and check it. If we had subtracted 5, we'd have gotten x equals 15, and when we went back and checked it, we'd have found out that doesn't work. That's why you want to check. That's why you want to check your answers. Don't forget. Okay, 4 minus 3a equals 22. First up, Madeline.
How do you know if subtraction or addition? You add.
The opposite, so it's add.
Yeah.
Okay, so,
You don't have to.
AJ,
Subtract 4 from 22.
Yeah.
you subtract 4, okay, and you're subtracting 4, remember, and I know what you meant when you said that, but you're subtracting 4 from both sides. You're subtracting it from both sides, because you're going to subtract it from the 4, you're going to subtract it from the 22,
Oh.
which is going to leave you with a negative 3a equals 18. So, David, what's my next step going to be?
I don't know. Negative 3 divided by both sides.
Okay, or both sides divided by negative 3. That's going to give me a equals negative 6. Okay, 19 equals 2n plus 4. Carson, what's my first step?
Subtract
Subtract what?
4.
From? And?
4.
Subtract 4 from both sides. Equals 2n. My next step. Kelby, what's my next step?
Oh my gosh.
DeAndre, what's my next step? Divide what? By 2. Okay, divide both sides by 2. Okay, I'm going to use 2 because that's my coefficient on my variable. Okay, so that's what I always want to divide by because that gets rid of the coefficient. It puts the variable by itself, which gives me 15 halves equals n. Or if you converted that to a decimal, it would be 7.5. Now, a certain number added to 17 yields a sum of 29. What's the number? Give me the equation. I want you to write down what the equation is going to be and then what the solution is going to be. The equation using the variable and the solution. Okay, write it down. Write the equation that you need to solve that problem. Write it out as an equation, and then solve the equation. Write out the equation and then solve it. Equation should have a variable. The equation will have a variable.
I have a variable.
Oh my gosh, Chip. I'm not
Okay, so,
Hold on, I got it.
It's really not. It's hard for me.
okay, guys, focus back up here. Okay, so when you've got a problem like this, when it says a certain number, that means your variable. A certain number added to, what's added going to mean we're going to do for an operand? We're going to add, so we're going to plus 17. And yields, what's yields mean? Equals. So n plus 17 yields 29. Okay, so n plus 17 equals 29, and then all we have to do is solve for n. Okay. Okay, so n can represent the number to be found. That's declaring the variable. So 17 plus n, or n plus 17, equals 29. Subtract 17, we get n equals 12. Try another one. 6 years ago, Bill was 13 years old. How old is he now?
6 years.
What's the equation? What's the equation for that? And then the answer. Write it down on your paper. What's the equation?
How old is he now? So he's gonna be 6 years ago.
Okay, so if we let y represent Bill's age now,
It should be X.
we let y represent his age now,
No, we can't. I got it. Wouldn't that be? Oh, Jesus. Okay, so like, that's for X. You can't say it to yourself. Oh my god. You didn't even know what it was.
Okay, you need to write your equation using a variable. The variable would be his current age. Six years ago tells us we're going to do what?
I swear I saw Austin. I saw Austin this morning. I swear I did.
He was here. All right, so what's
I know. I know. Oh wait, I have it wrong.
Nick? What's the equation going to be?
There you go.
Y minus 6 equals 13. Okay, y minus 6 equals 13. The next step, Armando, the next step. Okay, good. Add 6 to both sides and we get y equals 19. So Bill is presently 19 years old. Okay, Betty worked 8 hours Saturday and earned $60. How much did she earn per hour? The equation, write down the equation and solve it.
No, I do. You just gotta. What? You know, he's
Guys, let's solve this problem.
So it would be 60. Got it.
Dr. Crandall, are you allowed this? Are you allowed this?
All right, so looking around, most of you had this right. Most of you had it right. Okay, if we let X represent the amount Betty earned per hour, then we have, what are we going to have, Stephen?
8x equals 60.
8x equals 60.
I got 8b.
That's what I got.
No, you didn't.
Okay, so how much did she earn per hour? How much did she earn per hour? Bailey, how much did she earn per hour?
We would divide by 8, right?
Yeah, that was part of it. You had to solve it too.
Oh, I didn't solve it.
Okay? Okay, we're gonna divide both sides by 8. You got it, Bailey?
Oh,
Or
7.5. 7 or 50 cents. Take it down. Take it easy.
she made $7.50 per hour.
I get a really one.
Bye, bacon.
Okay, so she makes $7.50 an hour. Okay, Kendall paid $244 for a CD player and 6 compact discs. The CD player costs 10 times as much as one disc. Find the cost of the CD player and the cost of one compact disc.
I hear when they're so long. Hey, don't think I'm talking. Hey, I'm asking him about this problem.
I'm gonna say, who pays that much money for a CD?
Because I'm kidding.
Okay, so if we let D represent the cost of one compact disc,
You guys be quiet.
244 is going to be our equals. 244 is going to be our equals. For the price of the CD player is 10 times the cost of one CD disc. That plus 6 CD discs equals 244. Okay, so guys, let's look at this. Read you just have to read this. $244. So that's my total. So the CD player is, and I also know D is going to represent one disc. The CD player is 10 times as much as one disc. So the CD player is 10D. 10D. I bought a CD player and 6 discs, so this plus what is going to equal 244? Somebody said it, I think.
6 times X.
6 times D,
Oh, yeah.
because I'm using D for my variable. So 10D plus 6D is going to equal 244.
So 16. Which is 15.2 something. 0.5252525252. Right?
Okay.
Oh, just 0.25.
So
What?
the cost of one CD disc is $15.25.
I got it right.
I got that right.
How much is the cost of the CD player?
150. No, 10.
What's the cost of the CD player?
$152.52. And 50 cents.